Let's start now. Sorry for a small break between our lecture, please. And remember, we are doing last time the gas elimination, simple gas elimination method. And the gas elimination, what we have to do, we have to start with the augmented matrix A. Augmented matrix AB. And we have to convert into upper triangle system. And then we use backward substitution to find out the solution of the linear equation. Sorry. Now, in the case of the simple gas elimination, we say if at any state diagonal element becomes 0, we interchange that row with any below row. But if not, we will not change anything now here. But sometimes what happens, if your diagonal element become very, very small, we cannot change it. And in that case, you have a very bad approximation. So for this one, we use a second variation of the gas elimination, which we call it the partial pivoting. And partial pivoting, same idea that we use here. The only thing is what we have to choose our diagonal element by ourselves. We have to choose each diagonal element in the column must be largest in absolute sense. So when we choose our diagonal element in each column is the maximum, then we have a chance of small element or 0 element in the diagonal is almost finished now. We take the example, for example, this one. He said that solve this example with the help of partial pivoting. So we have to do what? In the simple pivoting, we do what? We see the first diagonal element is not equal to 0. We make below all 0. Then we check here, then we make 0 and we convert into the upper system. But in the case of the partial pivoting, what we have to choose? We choose in the first column which element is big in absolute sense. So it's 4 is a maximum. So we take 4 as our first diagonal element. So we replace this last equation by the first one. And we have this shape now. Now rest is the same thing. We have to make this element and this element equal to 0 by defining M21 is what? Is 2 taqsim by 4. And to make this one 0, we define M31. Same like before we did. And we multiply first row by half. Subtract here, this will be 0. Multiply first row by 1 by 4 and subtract here. So we will make this one 0 and we have a new shape of the system is this one. Now we have to look second column and we have to look which one is the maximum. We don't care about negative. If it is negative or positive, because we have to consider in the absolute sense. So 3 by 2 is what? 1.5 and 5 by 4 is 1.25. So it's mean this is a maximum. So when this is a maximum, no need to interchange it. If it is the maximum is this one, then we interchange because we have to make our diagonal element must be the maximum. So this is not, so it means we have to make this one equal to 0 by defining M32 is by this one multiplies second row by 5 by 6, subtract here, and inshallah you will get this upper triangle system which we need here now. And now you use backward substitution. X3 equal to what? Easily you see is 1. You put X3 equal to 1 and simplify, you will get inshallah X2 is -1 and go back here, you will get. This is a solution we have with the help of the partial pivoting. So what is the difference between partial pivoting and the simple pivoting? In the simple pivoting, we always start with the first diagonal element, and it should not be 0. If it is 0, we interchange with any below row. If it is not, we make it 0 and convert the given system into the upper system. But sometime what happens? That diagonal element become very, very small, then simple gas elimination is not work very well. So we move to the partial pivoting, and partial pivoting is what we have to look each step. In the first step, we look for the first column, which element is the largest in absolute sense. The 4 is the big. If it is -4, still we take in the first row because -4 is bigger than 2 and 1 in the absolute sense, but we will not change the sign of -4. But here, alhamdulillah, we don't have a minus, so we will change this last row to the first one, and we have this shape. But now it's the same way. Make all the element below the diagonal 0. We have this shape, and then we look for again which one is maximum here. And of course, 3/2 is maximum, then 5/4. And this means we have no need to interchange because our diagonal element must be big, largest the rest of the diagonal, rest of the element in that column. And then we convert into the upper system. And when we have the upper system, then we have backward substitution to find out the solution. Okay. This is a simple procedure, we call it the backward substitution. Also in an exam, teacher can ask you that find the inverse of the matrix by using gas elimination with the partial pivoting. So I use this example to find the inverse of this one here. So it's a very simple one now here. We have to start with the augmented matrix is this one. We start with, because we are finding the inverse of A. So what we do, we start with the augmented matrix A with I. I is a unit matrix and the size of A and I should be equal here. And this is your A and this is your I here now. So what we have to do, we use the same procedure of the partial pivoting and convert your system into the upper system. But when we convert into the upper system, over this side, the right-hand side, we not have a 1 column like before. We have a 3 column. So what we do here, you can see which one in the first column is big. 4 is a big. Though when we interchange this whole row by the first here, so we have this shape like this one. Now the thing is now, when you make it the big, make this one and this one equal to 0. And how can you make 0? You use the multiple like we did here. When you do, you can have this shape like this one here. And then you have to look for which one is maximum, this one or this one. And of course, this is 0.5 and this is 1 point something. So this is a maximum. So no need to interchange here. It's mean we make this position equal to 0 by defining this M32, which is 2/7. You multiply by 2/7 and subtract here, and inshallah you will get, this is the upper form here now. So this is U, and this is a complete matrix 3/3, not because we don't have a 1 column, we have the unit matrix, so we should have a 3 column. So now what you have to do, you have to solve, in this case, backward substitution by 3 times. What is the first time? Ux is equal to, let's I call C1. U is this one. And what is your C1? C1 is the first column, this one. Then you find out the solution, and that solution is the first column of A inverse. Then you repeat again, U is the same. Ux is equal to the second column of the split matrix become new. And then you have a second column of A inverse. And the last one you use backward substitution again for the third column here, which I did here like this one. When I use U, I use the first column, this one, and I find out this solution. This is what? This is the first column of A inverse, and which you can easily see. I find out that this is the first column. Then I repeat again the U and my second now, 0, 1, minus 2 by 7. This is my right hand side. And then I have the second column of A inverse. And then in the last, we have Ux is equal to the third column. And when we solve, we have this is the solution, and this is the third column of A inverse. And that's the things you have here now. This is called the A inverse of a matrix with the help of partial pivoting here. And when you have the A inverse, you can easily find out the solution of the linear system with the help of B given, because in this question, if you look for that one, in this question, he say, compute the inverse by using partial pivoting, right? And after you finding the inverse, you have to find out the solution of the linear system. This is your B, right-hand side. And then you have, when you have the inverse, then the things become very simple. Solution can be get A inverse into the B. A inverse you just find out, just multiply with the B given by the teacher, and that is the solution of the linear system we have here. So this is very good example. Also, please, in exam, teacher can ask you to find out the inverse by the partial pivot. So this is a partial pivoting idea. In the partial pivoting, as I told you, we have to choose our diagonal element by ourselves. We have to choose our diagonal element must be the largest in the absolute sense. Any question, please? Is okay?
Clear.
Good. So we finish our first method. Gauss-Jordan, we never have to do in our 254. The second direct method we have to do, it is called LU decomposition. Also one of the very good method to find the solution of the linear system with the help of the LU decomposition methods here. Now, it is in LU decomposition, what is the main things we have to do? We have to convert our A equal to ln U. L is your lower triangle matrix, U is upper triangle matrix, and we have to find the value of L and U with the help of A, and then we can move further here. After have the value of L and U, L is look like this one. You know the lower triangle matrix. Lower triangle matrix mean all the element in the diagonal below should not be 0, up must be 0. And what is your upper triangle matrix? All the element including diagonal and up should not be 0, but below must be equal to the 0 we have. So what we do, in the first step, we convert A into LU. And when we convert into LU, then we solve this two system. Ly equal to B. L, we know from the first step, B given by the teacher. You use forward substitution to find out the value of Y. And when you have the value of Y, you do the last step, Ux equal to Y we just got here. This is called LU decomposition. For example, I just give in the very simple way. What is the first step? In LU decomposition, we have to convert A into L and U. What is the second step? We have to do, we do Ly equal to the B, and L is a lower triangle matrix. We know from step number 1, B given by the teacher, and of course we use forward substitution. Forward substitution means we go from top to the bottom. We know Y1, we can easily find Y2, go down, and like this. We use forward substitution to find out Y, and the last step we have to do is what? Ux is equal to Y. U we get from the first equation, and Y we get the second equation, and this will give you what? After we use backward substitution, we will get what? X. That's the jawab of the problem we are interested in. Now the problem with that one here, you have to be very careful. Can any student tell me, let's say we are dealing with a 3 by 3 matrix. When we have a 3 by 3 matrix, how many elements we have for A?
9.
9 elements we have, right? And we have to find the element of L and U with the help of A. How many elements of L we have, please, and U element we have? For 3 by 3 case. This is the shape for the generalized case. 3 by 3 I'm talking about. How many? For L, what will be your matrix, please? L11, 0, and 0. This is the first row. L21, L22, and 0. And the last row is what? L31, L32, and L. How many unknown elements we have for L now?
6.
6. And the same way you can do U. What does U look like? U11, U12, U13, right? What is the second row for U? It is 0, U22, and U23. And what is the third row for 3 by 3 matrix? U33. How many unknown we have? 6, right? So for 3 by 3 matrix, how many elements we know for A? We know 9 elements. And with the help of 9 elements, we have to find the element of L and U. But you can see here, the element of L are 6, element of U are 6. So we have total unknown element are how many? Total unknown elements are 12, which is not look nice here in the sense we know element 9 of A and unknown element are 12. So this give you some problem, not give you properly the unique solution. For this case, we have to do LU decomposition by 2 different ways. By Dolittle way, sometimes we also call Dolittle way Gauss factorization. And the second one we call is the Gross method. So LU decomposition is possible by 2 different ways, by Dolittle way or by Crow's method. In exam, teacher must mention you LU decomposition by which way is. What is the Dolittle methods? Dolittle method mean the diagonal element of L should be 1. Diagonal element of L should be 1. How many elements now we have total for L and U unknown, please? For L, we have 3 unknown, and for U, we have a 6 unknown. So 3 plus 6 become 9, and we know 9 elements from here. So now we can find out here. Because unknown, 9, known, 9. So we can find out easily the unique solution, the element of L and U. Now, what is the Crow's method? The Crow's method is opposite. In the Crow's method, your U will be the unit. It means this will be what? L11, same, right? This is L22, and this is L33. But in the case of Crow's method, your U must be the unit lower, upper. And what is this one? Yes. This is, and this. So it means we need how many elements? 3 elements from U and 6 elements from L. So we have the all 9 elements for unknown and 9 elements we know with the help of this one. This is the things we have here now in the case of the LU decomposition that I mentioned. After you decompose A into L and U, we have to solve the forward substitution. What is forward substitution? We know Y1 is B1, and then we can find out Y2, Y3, going from top to bottom by using, this is called, procedure is called the forward elimination or forward substitution. And then we have the last step is UX is equal to Y, and we use backward substitution before, like that one we did here. We know Xn, then we go up Xn minus 1, Xn minus 2, and up to X1 we have. Now, this is a very good theorem that LU decomposition is not always possible. LU decomposition is possible only when this theorem exists. And what is that one? He said that if the gas elimination can be performed on the linear system without row interchange, mean you use the gas elimination, simple gas elimination method. And in the simple gas elimination method, as I told you, what happened? Maybe the diagonal element becomes 0. If the diagonal element becomes 0, we interchange the row. But if you interchange the row in the simple gas elimination, then LU decomposition is never possible. Direct LU decomposition is never possible. So it's mean if we use simple gas elimination method and we never interchange the row, then it's mean we can decompose, we can find the factor of A into the form of L and U. This is a very good theorem we have here now, please. Now let's do the first method of LU decomposition, which we call is a Dolittle method. Dolittle method, sometime as I also call you his the gas factorization here. Now, as I say, you need to find the element of L and U. L should be the unit lower, and U is a complete matrix, upper triangle matrix here. Now, to find the element of L and U, we have a two-way, please. In the case of Dolittle, please, first way is called the direct multiplication. What is direct multiplication? You are given A equal to LU. You multiply L and U element together and then equate with A and find the value of L and U, which is difficult. Not difficult in the sense here, slightly lengthy process, because first you have to very good in multiplication L and U. And then when you have the new matrix, you compare with A because it's an equal sign. That means the first column of this multiplication is equal to first column of A. Second column of A is the second, and then you can find out, you solve the 9 equation to find 9 elements. But the second method is very simple one, which I advise you to use it here. And what is that one? Is use simple Gauss elimination. Simple Gauss elimination. And you know what is simple Gauss elimination? What we do in simple Gauss elimination, we convert always A into what? The upper. This upper and this upper we are need exactly the same. What we need 3 elements of L. You remember this, to convert A into U 3 by 3 cases, what we need? We need 3 multiple, M31 and M31 exactly the same, which we need L21 and M31 exactly the same. We need L31 and L32, M32, sorry. M32 will be exactly the element we need. This one. This is the things we have. This is your A, and this is your L21, L31, and L32. This we have to find, and this is a U. So you do what? Use simple Gauss elimination, or you multiply. I give you the example for direct multiplication also, but I always give you advice, don't use direct multiplication. Always use the simple Gauss elimination. So what you do, use simple Gauss elimination, convert A into U, this U and that U exactly the same. To convert into U, we use 3 multiple, and this 3 multiple are the element of L we have here. Now that we need here. The diagonal element must be equal to 1. Now, can you give me what is the determinant of A by Dolittle method? Determinant of A always equal to determinant of L into determinant of the U. What is the determinant of L, please? Any student? What is the determinant of L?
1.
1. So it's mean determinant of A always equal to determinant of U in the case of Dolittle method. If teacher in exam, teacher say, find the determinant of A with the help of LU decomposition by Dolittle method. So you have to do what? Determinant of A always equal to determinant of U, because we know determinant of L always equal to the 1, because the diagonal element is 1, 1, so always is 1. Let's do the example 1. This is the first example we do here now. He say construct LU decomposition of the following matrix using the Gauss factorization or Dolittle methods here. So this is the things you have here now. This is your given matrix, and you have to find the element of Ln, the U. So as I told you, what you do, you use the simple Gauss elimination. And when you use a simple Gauss elimination, what is the simple Gauss elimination method say? Diagonal element should not be equal to 0. Then make this one and this one equal to 0. This should not be equal to 0. Make this one equal to 0 and convert into the u, upper one. So this is not 0. So we can make 2 and 1 equal to 0 by defining M21. And I told you M21 in the Dolittle case always equal to L21. So which is this? And you multiply first row by 2 and subtract here, and inshallah you will get exactly the same this row. Then what is your M31? Is 1. You already know how to find M31. And this is your M31 always equal to L. M31 always equal to L31, the unknown element of L. So you multiply first row by 1, subtract here, and you will get this shape here now. Now you have to look, this element position should not be equal to 0. It means you can make it 0 by defining M32, and M32 is exactly the L32, which you can have here. And you multiply second row by 1 and subtract here, and you will get this one. And this is what? This is a shape of upper which we are interested. And this upper and the decomposition exactly the same here. So what we have, A equal to L and U. L is what? The diagonal element is 1, 1. L21 is what? M21. L31 is what? M31. And L32 is what? M32. And this is a U exactly the same. And this is your the LU decomposition by using Dolittle methods. Let's I give you the complete example for this case. About 99.9% chance an exam teacher can give you this example. This is very good example. And he say that construct LU decomposition of the following matrix by using the gas elimination method or Dolittle method. Find the element of L and U like this one before we did. Then he say find the value of alpha for which the following matrix is singular. And what is the singular matrix mean? It's mean determinant of A must be equal to the 0. Then the second part he say find the unique solution of the linear system. This is your B by using the smallest positive integer value of L. Last, we do what? We convert over A into the upper one by using simple gas elimination method. So you have to find out the element of L and U. So what you have to do, this is not equal to 0, then you have to make this one and this one equal to 0 by using the multiple. So what is your M21? Is a -1. M21 and L21, I told you exactly the same in the Dolittle case. And what is M31? M31 and L31 is the same, which is alpha. So you multiply first row by -1, subtract here. You will get, inshallah, this shape. Then multiply first row by M31, which is alpha, and subtract here. And inshallah, exactly you get this shape now. Then this is not equal to 0. Make this one equal to 0 because we have to convert into the upper triangle system, upper triangle matrix. So we define M32 and M32. I told you exactly the L32, the third element of the L. And then you multiply second row by 1 by alpha, subtract here, and inshallah you will get, this is a shape, and this shape is what? This is your upper triangle matrix. And upper triangle matrix, we need here exactly the same we have here now. And what is the element of L? Diagonal element is 1, 1. L21 is what? -1. L31 is alpha, and L32 is what? 1 plus alpha. So this is your LU decomposition. You find the element of L and U. Now the question is what? He say, find the value of alpha for which A is a singular. Your A is a singular. When your A is a singular, please. Your A is a singular when determinant of A is equal to what? 0. What is the determinant of A in the case of Dolittle method? Please, I told you the formula. Determinant of A is what? In the Dolittle method?
Determinant of U.
U. So we can say determinant of A must be equal to determinant of U. And what is the determinant of U, please? 1 multiplied by 1 multiplied by 1 minus alpha. So which is what? 1 minus, let's I use alpha A, 1 minus A square. And this must be equal to what? 0. Because the condition is given here for which value it is a singular main determinant must be equal to 0 here. And when you solve this one, what you have? The value of alpha, maybe -1 or is 1, because 1 minus A square equal to mean A equal to plus minus 1. Now you do the second part. And the second part, he say, find the unique solution by using the smallest positive integer. So what is the smallest positive integer? Alpha value you will choose, please.
1.
1 we cannot use for the unique solution because 1 give you the problem. 1 give you the singular, and singular system never have a unique solution. He say, use smallest positive integer value to find the unique solution. It's mean we cannot use alpha equal to 1. We can use the very next integer, and very next integer, positive integer is what?
2.
Is a 2. So we use 2 here. And then we solve the system. And how to solve the system by LU decomposition? I told you is what? Ly equal to what? B. And Ux is equal to what? The Y. So this is your L. This is your U. Now you have to change alpha by 2 here. So that's I give you here. That this is a value give you singular case, alpha plus minus 1. To find the unique solution, we have to take very next positive integer, smallest, which is 2. And then you have, in place of alpha, you put 2. So 1 minus 1, 2, 3, 1, like that one here. And in place of alpha, you have 2 here, and 1 minus 2 square 4, so minus 3. So we have this shape here. Now you use Ly equal to the B. L is this one. Y you have to find out, and B given by the teacher is this one. So you have right in the system form. So we have this one. And then use the forward substitution. Forward substitution means from top to bottom. What is Y1? Y1 is a 1. You put Y1 is here now, go on down, -1, you -1 you take on the other side, it's become +1, so 2, Y2 equal to what? 2, you put Y1 is 1, Y2 is 2, so then you can simplify, you can have Y3 equal to -6. Then you use the last step, Ux is equal to Y. You already know this is your U. Y you just find out is this one. Now you use backward substitution. -3x3 equal to -6. It means x3 equal to 2. Go back here and inshallah you will get, this is a unique solution of the linear system we have. So that's a very simple things you have here now. Please, you have to remember that one. In this question, teacher can ask you two things. First, he say, find alpha. That condition is what? Determinant of A must be 0, singular. A is a singular. So you have to do what? You have to find, first step is what? You have to find ln u, and then you have to show determinant of A must be equal to determinant of u must be equal to 0. That will give you the value of A now, alpha. And then he say, use the smallest positive value. So you will not use the value of alpha which you got from this equation. You have to use next positive integer value. Then you have to solve it what? Linear system. So Ly equal to B and Ux equal to Y. So you have a unique solution of the problem. This is called LU decomposition by Dolittle method. LU decomposition by the Dolittle, the methods we have here now. Any question, please? This is the example I give by direct multiplication, which I never advise you to use this one, but I will mention you here now. I'm not using simple gas elimination. I'm using direct multiplication. And direct multiplication is what? You have L and U, element of L, unknown are this. An element of U, unknown are this. So we have to find out how many elements, 9 elements. We have to find 3 from here and 6 from here. And then you have to multiply this together. And when you multiply, you have, inshallah, this shape. And here, if you make small mistake in the multiplication, everything goes wrong here. So you have to be very careful in the multiplication if you're using direct multiplication to find the element of ln u. After you have this one, the first column of A given by the teacher, the first column of A equal to first column of this one. And then you have to solve with this equation. You have to find the value of, and the second column of A equal to second column of this. Again, you have to solve it. And the third column of A equal to third column, like this one, you have to find out. And then you have to find out 9 elements, which is difficult. It is not very easy way to find out in that sense here. You got my point here? So it's mean, my advice, not use direct multiplication to find the element of L and U. Just use simple gas elimination. And simple gas elimination convert your A into U. That U and this U exactly the same. And to convert A into U, we use 3 multiple. And that 3 multiple are the element, unknown element of the matrix L. Got my point here, please. This is the example I solved completely like this one without, by finding direct multiplication we have here now. The same example we can do like this one here, please. He says use LU characterization to find the value of alpha for which the linear system has a unique solution and infinitely many the solution here. So what you have to do here, you use your A. What is your A given? 1, 2, minus 1, 0.5, 3, 1, this alpha, and 1, 2.5. This is your A given. And then you find first what? You find ln u. And when you find ln u, you know how to find. We use simple gas elimination, right? I mentioned here, use simple gas elimination. And we use this 3 multiple, this 3 multiple help us to convert over given matrix A into the shape of U, which is like this one. And after this one, you can easily find out this U, exactly the U, and the unknown element of LR, M21, M31, and M32. This is the things we have here now. Then after having the solution of L and U, element of L and U, find out, and then you use Ly equal to B given by the teacher, and then you can find out the solution. And the solution L is this. Y1 is 0.5, Y2 is -2 and 0, and then you use this one. Now, you are finding the unique solution, please. Here, the question a student confused. When they find the unique solution, we use Ux is equal to Y, right? What does the unique solution mean? What is your last equation, if you can see? The last equation is this one. If you want to find a unique solution, please, what is the condition of the unique solution? The condition of the unique solution mean the diagonal element of U should not be equal to 0. Of course, 1 is not 0, -4 is not equal to 0. It means this diagonal element should not be equal to 0. And that's the things we have. Please remember that one. When I say AB equal to 0, what does this mean? AB equal to 0 mean either A0 or B equal to 0. It's mean when we say for the unique solution, we say the diagonal element should not be equal to 0. It's mean 1.5 alpha plus 2.25 should not be equal to 0. When this is not, A is not 0, it's mean B must be 0. It's mean your X3 equal to 0. And when your X3 equal to 0, so we don't need the value of alpha here. Directly we can solve it. We can find out X2 with this. And this is, you will get, inshallah, the unique solution here. The second condition, he say, infinitely many solution. Infinitely many solution mean one of the diagonal element must be equal to 0. It's mean the for infinitely many things, this diagonal element must be equal to 0. And when you have this 0, you can easily find the value of alpha is -1.5. So just solve this one here. When you put this is 0, your last row is equal to 0. So you have 2 equation and 3 variable. You always have the infinitely many solution. You have alpha equal to -1.5. You put here and you choose your X3 is any number, not 0. I choose T, and then you can find when you choose X3 equal to T, then you can find X2 in the form of T, which is inshallah this one. And then you have put X2 and X3 here value, you can easily find the value of X1. And this is the infinitely many solution. Why we call infinitely many solution? Because first condition we say we make the diagonal element is 0 of the upper, which makes singular, and singular never have a unique solution. And therefore we put T. T is any number, but not 0. Then you have the infinitely many solutions. So this is also the good example we have here now, please. We continue inshallah next time. I take your attendance, please. Number 1. But to remember that when I don't know what happened with you, Wallah is not a very good exam. The quiz you have here is not difficult. And in the quiz, many students, they submit late. Wallah, I don't know. Many students submit late. And this is a problem, Wallah. I will discuss inshallah later on. Number 2. Number 3. Number 4. Number 5. Number 6 is okay, now delete. Number 7. Number 8.
Abdurrahman.
Yes. Abdurrahman bin Ibrahim. Number 9.
Yes.
Yes, حاضر.
Number 10.
فراس
11. 12. 13.
زمان يا دكتور
12 is Khalaf. 13. 14.
Yasser, is it 14 or 15 now?
Yasser is 14.
Okay, Yasser. Yes.
عبد الرحمن زمام يا دكتور
Huh?
عبد الرحمن
Abdul Rahman, you are 13.
اوكي عبد الرحمن زمامي
Yes.
Yeah.
15.
Ahmed, Dr.
15.
Badr.
Yes. 16.
احمد
17.
فيصل
18. 19.
Muhammad Fahad.
Muhammad Fahad, very good. You got a very good marks, huh? How many marks you have?
And the quiz
Yes.
10.
Alhamdulillah. Very few students, 10. Wallah.
Thank you.
20.
Saud, yes.
21. 22. 23.
Yes, Dr. Walid.
Walid, you have one
Yes.
mistake in the quiz, I think. One question mistake.
Yes.
24.
Yes.
24. 25.
Yes, Mansoor.
Mansoor, also you have a one mistake, I think.
Yeah.
26. 27.
أحمد
Ahmad, you late. 28. Azam. 29.
Yes, Dr. Faisal Abdullah.
Faisal, how many marks?
10.
Alhamdulillah. Say Alhamdulillah. Don't say 10. Say
Alhamdulillah.
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 Yeah. 30.
فيصل القحطاني
31.
Yes,
30.
Abdul Karim.
31 is Abdullah bin Said. 32 is Abdul Karim.
Okay, 32.
One mistake. 33.
Yes.
34.
Abdulaziz.
Abdul Aziz, late and bad marks. 35. 36.
Mishal Abdullah.
One mistake, huh? 37.
Yes.
38.
Yes, Muhammad.
One mistake. 39. 40.
يس عبد العزيز عبد الرحمن
Alhamdulillah.
يس الحمد لله
Alhamdulillah. 41.
عبد الله محمد
Abdullah Muhammad, you have a two mistake, I think.
يس الحمد لله على كل حال
Alhamdulillah, still. 42.
Yes,
Yes,
Ahmed
sir.
Saad.
42. Ahmad bin Masad, huh?
Yes, here.
Okay. And 43.
Usama.
Osama. Two mistake. Continue inshallah more next time and we discuss the marks in detail. Right?
Doctor,
Yes.
Dr. Rizwan,
Yes.
my number is
Migran sent in the chat.
Say what? I didn't see the chat here. I'm just doing this one.
no, you said